All right. Thanks a lot for sticking out to the very tail end of the conference. And let's see if we can go out with a blast. My name is Martin Skarsaune. I'm a developer and co-owner at a consultancy company in Norway called Cantega. You see my contact information on screen. It's also fairly easy to look me up. It's pretty globally unique name, at least in this industry. So I'm a regular developer working full-time on client projects, but in addition to that, over the years I've liked to look into various tools surrounding the environment, such as compilers, debuggers, and today we'll look at monitoring tools. So a very quick intro to set the mood, so to say. So you're feeling rather content. You just deployed your shiny new feature to production well in time for lunch, and things are looking up. But then all of a sudden something happens. So what we will focus on today will be non-functional stuff. Or the tools we will look at are typically used for that. So it could be application crashes, it could be some form of degraded performance, such as response times, etc. Perhaps using more CPU than you used to. As we learned on the first day, our applications are not typically CPU bound, but you should probably look into it anyway. It could be that you're not using enough CPU, that your threads are not getting the work done. You might have a memory leak. You might not have a leak, but that the footprint has increased for some reason. Or you might be leaking some form of resources, such as connections to database or whatnot. So what do? You gather together and start firefighting. Hopefully you have good monitoring and metrics in place so that you notice that something is up before your customers start calling you. Metrics are good at observing externally observable stuff of your system. And sometimes you also put it in to monitor more specific stuff, but very often they can tell you that something is wrong, but not necessarily why or where. Of course, you have version control, so you might, have a critical eye on your latest changes. Perhaps you roll the code back, and then you need to figure out, was it just a coincidence, or are the two related? Even if you roll back, it's not a permanent change, because somehow you need to figure out what was wrong with the code. Maybe it's a feature that's important, or a security patch or something. Of course, you have logs. Logs are typically more functional oriented, but you can sometimes derive out of that by analyzing what goes on where and get an idea where the problem is. Perhaps you enable some more logs or write some more logs and push out to learn more. Maybe you do a sort of extra critical code review together of that last piece of code. You make some hypothesis and maybe deploy some defensive code or whatnot. Maybe you can try load testing. Some people are very good at that. I'm not. So I don't have the highest confidence that I will be able to reproduce it that way. And just a funny story before we move on to the solution of all this. So I've shamelessly stolen some pictures from The Mysterious Life of Developers. Have many of you seen that one? Yeah, quite a few, at least in the middle there. So I encourage you to look it up. So that was some years ago. Some lucky/unlucky colleagues of mine were made into movie stars for a day, and the whole thing went viral. And I think the funniest part is the reactions, which are mostly positive. But then it turns out some people don't understand satire. But the funniest, I guess, for us in the company is all the people who are convinced that these are not real developers, but professional actors. And to disprove that, we have this guy here sitting in the middle with us today, and he's a very good developer. So if you want to say hi to a viral phenomenon, you have the chance today. All right, so today we'll focus on the Java flight recorder and use a tool called Java Mission Control. And The cool thing, so naturally the name is inspired by aviation, by black box. So it collects lots and lots of information about what goes on deep inside the JVM. And the typical use case is you enable a flight recorder, you do a recording, and then you can do an offline analysis at the comfort of your laptop. It is suitable for production systems. Typically, it's quoted around 1% to 2% overhead. In a presentation yesterday, I was made aware that there's a bit more variance, but you can also tune it. So for all the systems I've ever worked on, I find that a no-brainer, a very good trade-off, especially when you're working on critical stuff. There's no need for you to create a new deployable or anything like that. This is part of the JVM you're running on. So it's just a flick of a button, and you can use it. This is something very few other environments can compare with. It's open source. It was donated during Java 11, and it's later been backported to Java 8. So you probably have it where you run your code today. You can also, since it's a recorder, you can also have your own application-specific events recorded. And I will give a reference to some talks yesterday who did that. And then Java Mission Control used to be in the bin folder of Java, but now it's an independent project on GitHub. So they have their own release schedule, independent of the Java release cycle. And it's you can write custom reports. And it's also plugin based, which we will make use of later. It's based on the Eclipse rich client platform, so you can extend it with plugins. Yes, so let's get to it. And so, as in all the other presentations, we have the pet clinic application running, and we will start a flight recording. And this will run for a minute. And let's just make sure it's not completely idle. So it seems when I'm running from IDEA, I lose the CSS, but never mind. For the ones of us who have been working since the last millennia, I guess this gives a rather nostalgic feel to it. It can trigger some exceptions and so on. What I should also then take the chance while it's running is to point out, so I had a real blast last afternoon. They were coming thick as thieves. So there's a talk on profiling, history of profilers, how they work. And he also covers custom, Johannes covers custom flight recorder events. Really, really good talk on profilers. And then the guy in the middle, Brian, caused a lot of the problems we'll see today by securing the containers. And then Anna Maria did a lot more of command line stuff and more tooling and experimenting with these things, which is kind of different today, because today we're not able to do those things. That's kind of the point. But with all this coverage of the Java flight recorder, we can then solely focus on getting recordings done and retrieving them. And then you can refer to other resources for more in-depth flight recorder. So we can see, so I will only touch on this very lightly, but perhaps we could point to some stuff that we learned during the conference. So you see you get a report on the starting page here. I have put a password and environment variable on purpose, of course. I would never do that. There is some stuff on memory allocation over time. We will look more at memory later. You have the threads. So like if you have thread starvation somehow, you can look at the timeline here, what they've been up to. I think the main use case for flight recorder is profiling. Even if you don't have a performance problem, it might be a good idea just to look into where the time is spent. Like if 95% is in Hibernate, doing some traversal of your data models, for instance. It might be nice to know. There's been talk in the conference about startup and warm-up times. So you do have both class loading and just-in-time compilation. So, and you can also start the flight recorder when you start the virtual machine. So you could compare different strategies and see how that turns out. And just as basic stuff as environment variables and system properties that we will see may not be so easily accessible. Yeah, I think that covers it. So let's see a bit on how this all works. Everything is based, or the interaction you see between mission control and the Java virtual machines are based on JMX, which is a subsystem in Java. It's really old. It's JSR 003. You have these mbeans that you can think of like objects, and they have attributes and operations. Mbeans are either Java language system core things. It can be third-party things, and you can even expose operational attributes of your own application via mbeans. And we will get back to the RMI protocol. So if we come back to mission control here, we can close this recording. So we did have the pet clinic application here, and here we have the mbean server. And there's some different tabs with some fancy views here with some graphs and dials and stuff. But everything you see is based on the stuff you see in this tree browser here. So for instance, if you look at the runtime, we'll use this example later. The name attribute of the runtime is the process ID followed by the host name. We could have an example of a third-party mbean. So we have a JDBC connection. We can here even at runtime edit an attribute. As an example of an operation, it appears there's a cache here. And lo and behold, there's a method to clear the cache. So like if you're doing some troubleshooting, perhaps forcing a cache upgrade could help you do some stuff. The flight recorder itself has an own bean with methods for doing what we aim to achieve. And very convenient. You see all our local Java processes show up here. And that's the case for a lot of the tools you find in the bin folder of your Java installation. And we can have a look at how all that is possible. So if I look at, so there is the temp folder. There's a directory which is called this name here, and then suffixed by my username. And there will be one file per running Java process. The username part is important. I was so lucky to work on Windows servers for maybe half my career, where the services would run as a system user. Then you would not get this kind of access, but then you can use some of the other things we'll see later. So if you, for instance, run JPS, you will see that the process IDs here correspond to the files that you find in this directory. There's yesterday in Anna Maria's talk, there was a lot of use of JCMD. So this is in fact a one tool does all kind of thing now. So you can do JCMD. So if you have console access to the environment, you can do JCMD and the process ID and help. And you get a long list of all the things you can do towards this JVM. For instance, start a flight recording. So if I look for help of that, you get more details on how you, from the command line, can trigger a start recording of a running JVM. Yes, but then the problem started because we were told we needed to deploy this stuff in the cloud and not run on regular boxes anymore. So a very simple setup here. We have a couple of pods. In the pods, there's one container. In each container, there's a JVM. In the JVM is the pet clinic application. And then there's a service that gives, the pods qualify for the service, and request to the service will go to one of the two, and there's an ingress. So it's just very simple. So whenever we do something here, it will hit one of the two pods. So if you look at the pods, we see there's 2 pet clinic applications, and there's one here for each deployment, and each pod will have a unique ID thing here. So say that, okay, we have a problem, and we want to troubleshoot something in that pod. Let's see. So, okay, we look at the Kubernetes manual. It says, okay, you do exec, and you open an interactive shell within the pod, and then you can look at stuff. The problem is that we have been nice boys and girls and saw the talk yesterday about securing our containers, so there is no interactive shell. But if there's no shell, there surely must be some executables in there that we could use directly. So, for instance, JCMD seemed very helpful, right? So if you can use JCMD towards process number 1, but it appears JCMD is not present. Can we look at the processes? Apparently not. Can we send a signal to get a thread dump, perhaps? No. Okay. Can we extract some data from it? For instance, a flight recording. And it turns out that you need the tar executable for kubectl copy to work. We could consider that, but we will look at other solutions that I think are better. Okay, it surely must have Java, right? Since it's running a Java application. What happens if we try to invoke Java? But then it turns out that Java tool options are hard-coded to start the application and so on. So we're pretty lost. Okay, then we look at the JMX documentation. Yeah, okay. Yeah, I think we kind of can do a recap. So the pods are sort of temporary in nature. You can't rely on the pod being there. They spin up and spin down, scale up, scale down. We don't have network access anymore. We shouldn't have console access. We miss all the tools, as we saw. File system might be out of reach. If you do something like Google Cloud Autopilot, you're basically saying, you do the infrastructure. We don't care. You spin up whatever you need. And my experience, less access now than in the good old cowboy days, when you could typically get some stuff you maybe shouldn't, when things were still on boxes and network cables. Yeah, so then if you look at the JMX documentation, it tells us, okay, you have RMI. Has anybody here worked with RMI? Actually, a few, yeah. So I have also been so unfortunate. So for the younger guys, this is the precursor to Enterprise Java Beans. It's JSR 160, so it's quite ancient. It's a binary protocol. For all intents and purposes, you need a Java client to use it. It's very complex because it's based on the client has to actually load bytecode from the server for the definition of the stubs you use. And maybe some firewalls and network people are not so happy with such an archaic binary protocol. But anyway, we have set this up. And in order to... So what we can do from Kubernetes is you can do a port forward. So I have set up RMI within the pod, and then I forward the RMI port of the pod to the same port on my local host. And now we can actually get a connection to the pod that way. And if I look at the kind of spells I needed to put in to make this work, we can actually look at it in a file. So actually, I made this work. I wasted a lot of time finding something that worked, and spent a lot of time looking in the wrong places in Stack Overflow. So it does work, and this is a kind of a minimum, I think. So this would have been worth my ticket to Devox alone if I knew this. So I guess we could, take an early stop of the conference. We have achieved what we want. We do get flight recording from within Kubernetes, but I thought it would be nice to look at some alternatives to this. So in 2016, I was at JavaZone and learned about something called Jolokia from a guy called Roland Hus. So this is then still JMX, but you have different ways to have this Jolokia running within your JVM, and it offers then the JMX data as regular JSON over an HTTP interface. We will see it might already be included. It's many ways to use it. We will see that it has granular security, which might be better than the RMI stuff, which is basically all or nothing. There's a discovery protocol, and so on. So if we come back to our example here. So this is a Spring Boot application, and in Spring Boot we have an endpoint called actuator, and it in turn contains a number of management endpoints, one of which is Jolokia. You see second from the bottom here. So if we send a single request to Jolokia, we see that it is running, it's alive, and some meta information. And the syntax is actually quite straightforward. So here we do a single GET request to Jolokia, and then we say we want to read an attribute. And then we have the name of the mbean here, similar to what we saw in the mbean browser in Mission Control. And then we state the attribute name here. And the response is like this. We get the request repeated, and the value contains the PID and the host name. So by offering this simple interface, you can use then very rudimentary tools, like I use curl here. So I could, for instance, do a loop. And yeah, here it's an mbean name and an attribute, and you can then drill further down into nested JSON structures if you only want parts of it. So we could then, of course, just open a port for Jolokia instead of RMI if you like that better. And the reason we can do that I forgot to mention, is since Jolokia, since Jolokia 1.7.0, there's a client library that will emulate the same kind of connection you get when you run inside the same VM or over RMI. So we can now substitute RMI with Jolokia as long as we have that client library. If we look at, we had this RMI connection here. This is a kind of a shorthand. Actually, there is a specific syntax for JMX service. So I have service, JMX, RMI, and then some more. And you see localhost in here somewhere, and the port name, and this path here. The client library uses one of the, I guess, oldest tricks in the book, whereas kind of plug-in or discovery mechanisms go. There's something called service discovery in Java. So there's meta-inf services. If you have a particular file name and point to an implementation, as long as this thing is on your class path, it can then be asked, can you handle this JMX URL? And it can then choose to respond. So this means that we can then instead here, and this also, so the client library needs to be present. But if if you write a little Java snippet to connect, you just need to have it on the class path. In mission control here, I solved this by having another plugin that contains the client library. So here we see we still have service GMX, but instead of RMI, it says Jolokia. And then actually the same path we saw from the command line. And we can connect via Jolokia instead to that server. We saw this one died, so just stop the port forward. So that's cool. So now we could use Jolokia instead, if we wanted to. And since if it was Spring Boot, it will already be present. If you're using some other OpenShift stuff, you might very possibly have a Jolokia port already. So you can do port forward, as we did with RMI, but I wanted this to take this a step further. Sorry. Since Jolokia is HTTP, and the Kubernetes API is also HTTP, there is a feature in the Kubernetes API which allows you to proxy a request directly to a pod. So as opposed to the traffic that goes through the ingress and the service, I can address a specific port. I think we'll see later why it might make sense to set up a dedicated port instead of, for instance, like letting Spring Boot do the job, as we saw in the local case. So you can send your requests directly there. Yeah. So in addition then, there's another plugin and another client library that builds on the first one. And in this case, it's Kubernetes instead of Jolokia, and it has the namespace. And here I put in support for doing a regexp. So sometimes when you do troubleshooting, it may be limited to one specific node or a specific pod. Sometimes it's evenly distributed. You just want the first and best, and it will pick one and stay with that. If that one dies, it will tell you that the connection was down, and you can try to reconnect. Yes, and then the port and the path to Jolokia within there. And now we can connect to that over Jolokia instead. And so far, everything I've seen in the user interface is supported. Then to take it one step further, so it was very convenient, right, with all these local processes magically appearing here. And I thought, could we like have a convention-based thing to make it simpler? Like if on the spur of the moment you need very quick access, you could have go in with kubectl and find the things and make the path and whatnot. What if we could do something similar to, so for the old RMI, there's a JDP discovery thing, Jolokia as well. So there's a discovery UDP thing. And I thought we could use, I will just apply this, and then we could, in the meantime, show. So one idea of a kind of setup you might have could be to have, instead of setting up Jolokia agent with very long command line, you can have a property file. So you could kind of standardize how you set up Jolokia. You could even have credentials in here, and I'll show why that is okay. And then you could take this property file, and you could expose it as, or store it in Kubernetes as a secret, and you can then mount it within all the containers. And in each container, you could then use, so of all the Jolokia ways to include, I think the most versatile is the Java agent. If you're unfamiliar with the agent concept, it's you have your Java application, and you can sort of just attach an agent to it. Your application has no knowledge of it. So the Jolokia JVM agent gives you access to the JVM. It spins up a tiny little web server on a dedicated port, default 8778. And we configure it with this properties here. And I thought then, okay, we could have some settings just use. So since Kubernetes has an API which knows about all the namespaces, the pods and whatnot, you could have this plugin look for pods with a given label, maybe look at path, either hard-coded or declared, and even port, HTTP or HTTPS. You could even fetch username and password from the secret, the same secret, or you could hard-code it here. There's some kind of secure storage. And lo and behold, we have then found lots of stuff. So this is my local, the one we've seen before, Docker desktop on my Mac. In addition, there's running on Kubernetes. No, sorry, Azure, Microsoft Azure. And then for the sponsors of the event, we also have on Amazon and Google Cloud. So sort of spread all over and use the same way to reach them. And I guess we could, if the objective of the talk was to see if we were able to do flight recordings even over Devox Wi-Fi, let's go for it and see if we can make it work. And while those run in the background, we could touch on. So the way this works is that in the mbin for Java flight recording, when you complete the recording, you can open a stream, and then you can read data in chunks from that stream. So you do this to pull all the data via the API. You don't need the file access. If you somehow are not able to do this, and one example is if you want to do a heap dump. For heap dumps, there's no similar way to stream the results that I have found. So in that case, if you're in a kind of cloud environment, one way to do it might be then to have some sort of cloud storage. And then tell it to be dropped there. Now it's Java Mission Control knows that this is not a local process, but it still opens a file browser locally. But I will have to see if I'm lucky, and so can then download this file since I mounted this file share that's in Azure into all the containers. There's probably some download, and then let's see. And I guess in the meantime we had all the flight recordings show up here. Let's see. Maybe it's done. Yeah, there it is. So if you open this in Java Mission Control, it opens a view called JOverflow, which has certain things. But if the main thing is now we have the heap dump on my disk, so I could also, for instance, use the Eclipse memory analyzer tool to look at it. This is sort of a dedicated tool. It has a lot of analysis and reports. You can write like object queries to sort of investigate and stuff. Very powerful tool. I think that more or less concludes the second part. Let's see where we are. So I wanted to offer yet another alternative. So on JavaZone 2017, there was this other crazy guy who talked about a tool called Hot.io. And this utilizes the fact that Jolokia serves regular JSON over HTTP, which means you can write a tool not as powerful as Java Mission Control, but you can create a user interface for doing JMX stuff with just front-end technology. It also has a lot of plugins, so if you're using a particular framework such as ActiveMQ, Apache Camel, Spring Boot, and so on, it will give you some nice visualizations of those mbins. It's also possible to, that's already included, similar to Jolokia, and it supports the Jolokia discovery protocol. And I will look at two different flavors of this. So the traditional one, which I've been used to in the past, is you can install it as a full stack Java web application where you don't have a Java backend. That's pretty thin, but it handles the connections to this Jolokia on other, and we'll see some benefits of that. And it also supports the Jolokia discovery protocol. And then you have the front end that gives you all the functionality in the browser. So this is kind of similar to like if you had not Kubernetes, but you had an old server room thing, and you would like somehow put in Hot.io among your stuff. Since you maybe were not allowed to talk to them directly, you could use this as a sort of way to get there. So if I'm running that flavor, so I can do the discover and see the two pet clinics, and I could connect to those. Now I will show one benefit of running the full stack thing. So if I do a flight recording here, if you've not realized it already, I'm a really back-end guy. So when you see the flashing red light and these rotating things here, that's the highlight or low point of my front-end career. But the thing here is I'm actually able to, via the browser, download the recording to my machine. And it's kind of a hack on, since it's it's a full stack Java, so we can connect to the VM, successfully read with these operations via JMX, and then constantly write to the same response stream out to the client here. There was also you do have some, this was also demonstrated yesterday. There's also, like we don't have the full, like if you cannot do heap dumps, there's also a class histogram thing here that you could repeatedly load, see at some diffs, look if there's any special things. I could also mention, where is it? Yeah. This diagnostic command mbin is actually the companion to, or what we could do in JCMD typically appear here as JMX operations. So the same thing we will do from the command line you can do here. It's very evident that it's kind of console based because it's very text input and text output oriented, but this is a way sort of to run JCMD where you are able to run JCMD over the wire. So this console management diagnostic command. And then there is another flavor of Hot.io, which is called Hot.io Online. It's also a pod, but it is more Kubernetes native. So it's actually just an Nginx with some JavaScript in it that benefits from the fact that it itself runs in Kubernetes. So its service account can also access the Kubernetes API, and it can then query the API for what other pods are out there. And so here you see the namespace and the cluster and some things, and then we can connect to one of those. So we can see if we look at the runtime here, we should see the name that we've been using. So as is process ID 1, and so it's the pod with 7. And you can also easily switch here, so among them, so I can get to the other pod. Maybe a couple of other things. So I mentioned that it has this. So you see on the first page, it didn't have this Spring Boot thing here. So it will kind of, by the absence or presence of certain mbeans, you might have lots of things in this menu here. So there's a Spring Boot thing, since it's discovered it's a Spring Boot. If it was, yeah. But when we look at it, it seems it's rather broken. And if I enter the loggers, there's a little hint here, but the reason I chose this as an example is that so Jolokia has sort of a very simple grant permission thing you can set up because so we have org Spring Framework boot here, and for the loggers I discovered that the loggers can allow you to see all the logs in raw format. So say you put a lot of effort into masking all the logs, and then you can use JMX and get hold of some stuff you shouldn't see, or some other, just an example. That there might be stuff in JMX that some deem is too powerful and not really worth it. So we can we see it easier. If I try to execute the loggers, it will say we're not allowed to do this. So the way we do that is for this demo, I've sort of started to restrict all, and then allowing, okay, we want mission control to show memory stuff. We allow write of a certain mbean. We want to support flight recordings. And some of the diagnostic stuff, but I have not put Spring Boot in here. So it's a kind of a castrated JMX, but you get the point that it's if people are concerned about JMX being too powerful, you can sort of as a counter argument say that you only enable certain things. Yeah, I think, let's see. I think that more or less covers it. Some references here. Also, I posted a slide deck and also put on references to the 2 of the talks from yesterday I talked about. Any other questions now? If not, I'm available. So thank you a lot for your time.